Hello, welcome back. And today we are finding roots using the quadratic formula. So when you're given a quadratic polynomial, ax squared plus bx plus c, let me go ahead and write that down. Ax squared plus bx plus c. And you set that equal to 0. Then what you can do is you can always find the roots using the quadratic formula. And the quadratic formula is going to be x equals negative b plus or minus the square root of b squared minus 4ac, where everything is divided by 2 times a. So this is the quadratic formula. The quadratic formula. And we're going to be using this to solve two problems where we need to find the roots of the quadratic polynomial. Now, before we do that, I wanted to show you how this formula includes the discriminant. The discriminant is equal to b squared minus 4ac. Delta is equal to b squared minus 4ac. And where we get that is from the inside of this square root. We have b squared minus 4ac. Now, there are three rules that you need to know about the discriminant. The first one is that if the discriminant is greater than 0, then you're going to have two real roots. Two real roots. If the discriminant is actually equal to 0, you're going to have exactly one real root. One real root. And then the third case is if the discriminant is negative, you're going to have two imaginary roots. Imaginary roots. So these wouldn't be real. They would be imaginary numbers, like a plus bi. Okay? So we're going to be looking at two problems and seeing how the discriminant and the formula help us to find the roots. So the first one I wanted to do was number 9 on the classwork. It is u of x is equal to x squared minus 8x plus 17. And I want to find the two roots of this. The first thing I do is I want to identify what my a, b, and c are. My a is always going to be the number out in front of the x squared. In this case, since there's not a number, it's assumed to be a 1. So a equals 1. B is always going to be the number in front of the x. In this case, it's a negative 8. And then C is always going to be the number left on the side. It's just going to be a number not attached to a variable. In this case, it's 17. So now we have all we need to figure out what the discriminant is. And once again, that is b squared minus 4ac. So I'm just going to take these three numbers and plug them in for a, b, and c. I know that b is going to be negative 8. I put that in parentheses because it's a negative number and we're going to be squaring it. I have a minus 4, a, c. I know that a is 1 and c is 17. The first thing I'm going to do is I'm going to square the negative 8. That would be negative 8 times negative 8. We're multiplying it by itself, and we get a positive 64. I bring down my minus sign. Over here, I have 4 times 1, which is 4. And 4 times 17 is going to give us 68. So the last thing we have to do is subtract these two numbers. We have 64 minus 68, which is negative 4. So we get a negative 4 for our discriminant this time. And negative 4 is indeed less than 0. So that means we're going to have two imaginary roots. Two imaginary roots. So these are going to be numbers of the form z equals a plus bi. Now I will remind you that when you square I, you do get a -1. That is the definition of I, the imaginary unit. So let me write that down. That is the imaginary unit, I. Okay, so now what we're going to do is we're going to plug in all three of these numbers that we found for A, B, and C into the quadratic formula. And as a reminder, the quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2 times a. We'll be using a equals 1, b equals -8, and c equals 17. So I first start off by plugging in all three of these numbers. I have a -b, that's going to give me a -8 plus or minus the square root of b squared. That would be -8 squared minus 4ac. A is 1, C is 17. And then I'm going to be dividing everything by 2 times A, which is just going to be 2 times 1. This double negative is going to give me a positive. And then under the square root, I know that this whole thing is just going to be 64 minus 68. 64 minus 68, which is going to be our discriminant, -4. And 2 times 1 is 2. So we're taking the square root of 64 minus 68, which is -4. And we're still dividing everything by 2. What that's going to do is that's going to leave us with 8 plus or minus the square root of -4, which is 2i. Whenever you take the square root of a negative number, you have to put an I at the end. So I'm going to be using 2i because the square root of 4 is 2. And then we're going to still be dividing everything by that 2 in the denominator. So when we do that, what we can do is we can break up the big fraction into 2 smaller fractions. The 8 is going to be divided by 2. And then the other part of the numerator, which is 2i, is also going to be divided by 2. 8 divided by 2 is 4. 2 divided by 2 is 1, so I don't need to write the 1. And I'm just left with 4 plus or minus I. Now, the plus or minus means it could be a positive or it could be a negative. So we're going to be getting 2 answers. We can take the positive answer, which is 4 plus I, but we can also take the negative answer, which would be 4 minus I. And then we close that up in our solution set. So these are our 2 imaginary solutions. All right, and then the second one we're going to do is number 10. V of x is equal to x squared plus 9. Now for this polynomial, we can rewrite that as x squared plus 0x plus 9. Since there's no x in the middle, we fill it in with a 0x. So that way we can figure out what a, b, and c are a little bit easier. The a is always going to be the number in front of the x squared. In this case, it's a 1, a positive 1. B is going to be 0. And c is going to be the 9. So our discriminant b squared minus 4ac is going to be b squared, which is 0 squared, minus 4ac, where a is 1 and c is 9. 0 squared is 0. If I multiply all three of these numbers, I'm going to get 36. And 0 minus 36 is going to be negative 36. That is our discriminant. It is less than 0, so we're going to have two imaginary roots, which means we have to use the quadratic formula to solve this. So we do that. So we need x equals negative b, that's going to be negative 0, plus or minus the square root of b squared minus 4ac, which is just going to be negative 36. And then everything is going to be divided by 2 times a, where a is 1. The negative 0 isn't going to factor into our answer any, so we can ignore it. We have plus or minus the square root of negative 36, which is going to be 6i. Square root of 36 is 6, and the negative turns into an I, and everything is being divided by 2 times 1, which is 2. 6 divided by 2 is going to give us 3, plus or minus 3i. Those are going to be our two imaginary roots. So I can have a positive 3i, or I can take the negative underneath and make it a negative 3i. So positive 3i and negative 3i are going to be our two imaginary roots. So that is using the quadratic formula when you have two imaginary roots. And I hope that helps.